Hello, this video is for CIS 200 Unit 9 challenge work. This is on page 23 of lesson 4. You click launch activity to open it up in Cengage. This one is a little longer and there's a few assignment twists, right? But that's all right. So now we're going to go to our document. And so the questions may be out of order, right? So I just want to list each question so that we can see um, what I'm doing. So I'm going to go ahead and Q1. Here's the actual question. Alrighty, so you just read the question, ensure that you're working on the right one, right? Now, for this one, this is going to be our task, okay? So write logic to open and read a file named data.txt containing a list of numbers. Store numbers into an array or list. Prompt the user to enter a target number to search for. Write the sequential search loop in pseudocode to check the list from start to finish. Print whether the number was found or not. Okay, and then here is the solution for that. So it's in pseudocode, right? So no particular language. Open data.txt for reading. Read all lines into list numbers. Close data.txt. Output. Enter a number to search for. Input target. That would be the number that the user inputs that they would like to search the list for. So here we go. Set found to false for each number in numbers do. If number equals target, then so if the number is found, set found to true. End if. So after end if, we would go to let's see, where was I? End if. Okay, now we'll go to end for. And then we say if found is true, then output target found, else output target not found. End if. So there we go. It's pseudocode. It opens a text file called data.txt that contains numbers. It stores them into a list called numbers. It prompts the user for a number to search for. It sets the found flag to false. It cycles through each numbers with a for loop. Then if it's found, it sets the found flag to true and it outputs target found. If not found, it outputs target not found. So you would go ahead and save this. Um, you know, save it, then save it as a PDF, then submit that PDF. Now we're going to move on to question 2. You would submit your PDF right here. Now we're going to move on to question 2. And for this one, I'm just going to copy the question, but it does this specific question. Again, they may be out of order, has figures 3.6 and 2.14. So here's the question. Now for this one, our task is going to be write pseudocode to open/read a file named unsorted.txt containing a list of numbers into an array. Create a separate helper function called a method, or sorry, called a procedure named find largest that mimics figure 2.14. So it mimics this one, right? To find the position of the largest number in the unsorted portion of the array. Write the main program loop using the selection sort logic from figure 3.6. So from this one, right? Calling find largest on each pass. So we call this, which we created right here, and we called on each pass of the main loop. And then write the final sorted list of numbers out to a new file named sorted.txt. All right, so now we're going to go ahead and close our solution. So I'm just going to do like a comment, right? I'm going to call this the helper function. So it's a comment. It's not an actual line of code, or in this case, pseudocode. So, but here it does begin. So function find largest array index set largest to array 1. So right out the gate, we're just going to set the first one in the array as the largest number. Set location to 1. We're going to do a for loop for I from 2 to end index do. Now, and if array I is greater than largest, then set largest to array I, set location to I. That's the end of our if. And we'll indar4, scroll up some, and then we return the location. And now we can go ahead and say end function. So that's the end of our find largest procedure that mimics figure 2.14. And now we can go ahead and start our main program. And this is from figure 3.6, the logic of that figure, right? So we're going to say open unsorted.txt for reading, read numbers into list, un sorted list, close unsorted.txt. That document with the unsorted numbers, we're going to close it. And we're going to say something like set marker to length of unsorted list. UN sorted list is unsorted list. Now we'll do a while marker is greater than 1. Do the following. So this is just a comment called the helper function. Set max location to find largest unsorted list marker. So here we're calling that find largest the helper function procedure that we made up here that mimics 3.14 inside of what we're doing where the logic mimics figure 3.6, right? So here I'd say like swap elements. It's just my comment. So set temp to unsorted list marker. Set unsorted list marker to unsorted list max location. Set unsorted list max location to temp. So you see it's just swapping what's in the temp to marker to max location, and max location to temp, right? Everything just moves. The name of our max location is max lock. Now we need to, of course, move the marker left. So set marker to marker -1, which just shifts the marker from where it is 1 to the left. Here we'll go ahead and end our while. And then we will open sorted.txt for writing. Previously we did for reading because we were grabbing the numbers from the unsorted. Now that we're opening sorted, we're going to write to it as per the tasks. Then we write unsorted list, which is now really sorted, even though the name is still unsorted list after all this executes, calling the helper function, and it concludes it is sorted. So we're going to write that to sorted.txt. And then, of course, we will close our sorted.txt. And that concludes question two. So now we're going to move on to question three. Again, verify each time, read the question because they may be out of order. So just be sure that we are each going through the same one. So we'd save it, of course, save it as a PDF, go over here, submit that PDF for question two, and then we're moving on to question three. So I'm just going to copy, the first two because it'd be pretty long, but just be sure that you know that this is the question that we are doing right now. So for this one, we're going to write a helper function, encode message array, length shift that takes an array of letters and shifts each character forward by the specified shift amount. Ensure that if a shift goes past Z, it wraps back around to A. And then secondly, write a helper function decode. So the first one was encode, this one's decode. With message array length and shift that essentially does the reverse, right? Reverses the encoding process to return the message back to its original form. All right, rinse and repeat. Solution. So I'm going to do the encode first, right? Procedure, encode. Again, this is pseudocode, right? So no specific language. Message array, length, shift. So for I from one to length do. So we're saying from I, for I, each I, which is going to represent the index from one, the starting position to the length, which we feed it the length, right? So it knows the max length and it's going to do each of the following. And I'm just going to put comments for what it's going to do. That's fine. Again, it's pseudocode. It doesn't have to be in a specific language. I'm extremely precise, just convey the logic of it, right? So one is going to convert letter to number, such as A equals 0, B equals 1, etc. Two is going to add shift and wrap around. Three, convert back to letter. So really simple, right? And then we're going to go ahead and say end four, and then we're going to go ahead and say end procedure. Alrighty, that was for encode. Now we're going to do the decode one, right? So for I from one to length do, convert letter to number. Right here, I forgot to mention we have to use mod 26, right? Because there's 26 letters in the alphabet, so we use modulo 26 in case so that if it's goes past Z, right? So let's say it's like 27, so it goes through the first 26 letters, A through Z, which is 26, and if it A's right on, we have to make sure that A's right on the other side of Z as the 27. So we use modulo 26. So same thing again, convert letter to number. And here we subtract shift, which is included right here, right? Of course, we have to account for adding 26 if it is negative. And then same as before, convert back to letter and for and procedure. And that is it for this one. You would go ahead and save. Um, submit, save it as the document, save it as the PDF, submit the PDF so that you have the document for your records in case we need to backtrack, right, for any reason. And then this is question 4. Save it right here. Go on to question 4. Just going to copy the question so that you can read it. Pause the video and read it to make sure that we're working on the same question. So here we go. And for this one, our task is complete the logic inside the loop to check if the target exists in the list. Update the tracking variable, of course, and print the correct outcome message based on figure 3.1, which is this figure right here. Read through it, and then you'll see what we're going to do. So now we're going to go ahead and start our solution. So you can just put the pseudocode here, right? You don't have to actually spell out the entire if. I just want to see the pseudocode. So we would say something like procedure, sequential search, list, link, target, set I to 1, set found to no. So while found equals no, and I is less than or equal to length, do the following. So all both these are true. While found equals no, and I is less than or equal to length, do the following. And then this is where our if would go, right? And I'm just going, you can just put the if and then put your pseudocode comment, right? Check if the current list item equals the target. And if it does, you set found to yes. If it does not, you set I to I plus 1. So you just increment the index by 1, right? Then we'll end if, and we will end while. Now here's the second if, right? The one outside the while loop. So it's in line with the while loop. You see how this first one's right here inside of it. This one's outside. So this if is going to check the final status of found to print the result, right? So if found, then output successful search. The value is in the list. Else, output unsuccessful search. The value is not in the list. Go ahead and end our if, and then we can go. So we just ended the if, right? With end if. Now we're going to end procedure. All right, that's it for question 4. Save the document, save it as a PDF, submit the PDF, keep the document for your records. And now we'll move on to question 5. Alrighty, so it's the routing problem. I'm just going to copy this first little bit right here, paste it so you know what's going on, but it has these two figures, as you can see right here. So for this one, we want to find out if path A14 via node 0 it is A4, 0 plus A0, 4 less than A1, 4. So we will go ahead and just, let's see. I'm gonna just call this question A inside of here, right? So does A1, 4 update? Yes, it does update. You can see that just by checking these two and going through the logic of Floyd's algorithm, right? Now I'm gonna say this A1, 0 plus A0, 4 equals 1 plus 3, which equals 4. But in the original, 4 is less than 4, which is false. So now for B is looking at is A1, 0 plus A0, 2 less than A1, 2? And does A1, 2 get updated? If so, what is the new value? So let's look at this. There is no update, right? A1, 0 plus A0, 2 equals 1 plus 4, which equals 5. and 2 is less than 5, or 5 less than 2 is false, so it stays 2, right? Alrighty, so now let's move on to shortest path from node 2 to node 4. So from node 2, this one, to node 4, you see straight from 2 to 4 is cost 5. From 2 to 1 is 2. From 1 to 0 is 1. From 0 to 4 is 3. So what is that? That is 6. So right now, 2 to 4 is 5. This path is 6. So 5 costs less than 6. Now let's see. From 2 to 3 is 1. From 3 to 4 is 3. So 1 plus 3 is 4. So even though it's a straight shot from 2 to 4, if you go to 3 and then to 4, it costs less. So this is the shortest path, right? So you could just say cost is 4, and then the actual path. So actual path of the nodes, it goes from 2 to 3, as we saw right there, from 2 to 3, and then to 4. 2 to 3 costs 1, 3 to 4 costs 3. So from 2 to 3, and then 3 to 4. You can state something like this beats the direct edge cost of 5, which we saw that direct edge cost from 2 to 4, just one edge, one direct edge, right? It costs 5. But if we take 2 to 3 to 4, it only costs 4. All right, you go ahead and save this. Save it as a PDF then, and then submit the PDF. Keep the actual document for your records. And then we will move on to question 6. Okay, I'm just going to paste it all. For mine, I chose black box and white box. Just a couple sentences for about either any one of these things in here is sufficient for the report, right? So just software testing is an essential phase of engineering that ensures code quality through two distinct approaches: black box testing and white box testing. Black box testing evaluates a program's external behavior from a user's perspective. Should say phase, not pages. From a user's perspective, without any knowledge of the underlying code. White box testing requires full visibility into the internal program structure, allowing engineers to test specific code paths, loops, and statement coverage. So black box testing just looks at what's input, and then the output result doesn't worry about what's going on the inside. White box testing gets into the nuts and bolts of it, of what's going on the inside, right? You can summarize it by saying, by combining both methodologies, software development teams can successfully detect external functional errors while, scroll up some, can detect external functional errors while simultaneously catching internal logic flaws and any security vulnerabilities. That is it. Just short and sweet for this one. Just a couple of pages. Doesn't have to be a full or a couple of sentences. Doesn't have to be a full multi-page report, right? That was question 6. Save it. Save it as a PDF. Submit it right here. And then that is it. That is all 6 questions. Please keep in mind, as stated previously, they are out of order. So that's why I pasted each question or part of each question right here so you can see which one that we're working on. I hope that you found this video helpful. Thank you for taking the time to watch it. Have a great rest of your day.